All right. Last class we talked about, let's go to the calendar. Last class was all about getting good data, making sure your data is not biased, with low variability, therefore high reliability. Today we're going to talk about sampling and how we can make sure we get good data, the different methods of sampling so that we get good, reliable data. So we start with the population. We'll then take a random selection, which will give us our sample. That is the whole sampling process. So some vocabulary. Population of interest, you should know. We should know the population is just the entire group of things or units of people that we want to know something about. So this is not new. Let me just make this a check mark instead of a star. We know that. We also know what a sample is. A sample is just a portion of the population that is selected to tell us information about the population. It's something that you can get information about that you can't because it's tough to get information from an entire population. Key to your sample is the sample must be representative of the entire population, and that will give you good statistics, which will tell you about parameters. Sampling frame is the list of all subjects from which the sample is taken. Typically, it's just going to be the population. The population will usually be your sampling frame. However, if there's a portion of the population that you just cannot get to for some reason, all of a sudden you could have a sampling frame that is a little bit less than the entire population. So it could be a little more selective. Random sampling is the technique at which we are going to make sure we get a good representative of the entire population that makes up our sample. Okay, so we will take a random sample, hopefully from our sampling frame, so that we get good data. So let's talk about the sampling and these sampling methods. Three good sampling methods: a simple random sample, random sample, which is SRS for short. So SRS is for simple random sample. Stratified random sample, we'll talk about. This is a good method. This also is an SRS. However, we just use SRS for a simple random sample, so know that. Talk about systematic sampling, and then we'll talk about the bad sampling methods, which is a voluntary response sample, convenience sample, judgment sample, and quickie polls. And we talked about these a little bit in the past. We'll talk about them more. So simple random sampling. Key for simple random sampling is it's like drawing names out of a hat. Okay? If we are able to put our entire population, names into a hat, each name that's pulled out would consist of our, would make up our sample, and each name is going to be equally as likely to be pulled out of the hat than any other name. Okay, it's just completely randomized. Okay, so this is a simple random sampling. Take the entire population, the hat, every unit has the same chance of belonging to the sample. This one little guy would be the unit, and all of these guys would make our sample. And every possible grouping of specified size has the same sample. So we make sure that every unit is in the sample, and then every unit has the same chance of being selected. So I don't want to say every possible grouping. It's kind of confusing. I'll just say every unit has the same chance of being selected. Every unit. Okay, names in a hat, pulling out names equally as likely to grab one name compared to another. Now, we will use a random number table to get a simple random sample. In your book on the last page, you will see just a table of numbers, okay? And we have like a line, like this could be line 111, this could be line 112. And we will use this random number table to obtain an SRS, and this is the procedure. We have a list. We will assign a number label to each unit in the population, And then we're going to read the numbers from left to right, starting anywhere. And the subjects selected for the sample are those read from the table. And I'll show you what I mean. Now, these are separated by 5s, but that's for no reason other than to keep the numbers organized and so that you know where you are. So you can think of this as just a continuous stream of numbers going 1, 9, 2, 2, 3, 9, 5, 0, 3, 4 with no gap in here, like these numbers are next to each other. The only reason why they're separated and they're separated in your book is so that you can just see them easier and read them and keep track of where you are. Repeats or those not a part of the list are ignored. Let's do that. So here's the same table. Here's a list of people, 50 people. This is our population. So this list of people is our population for maybe like a class or a team or something. And the goal is to randomly select 8 people from the following list. And we're going to randomly select them not just by closing our eyes and stopping. Instead, we will use this table. Now, here's how we use this table. I'll use the one on the top for my first go around. So we have numbers from 1 to 50. So these are 2-digit numbers. And I will read this table off in groups of 2. So group of 2, group of 2. Now 39 would be the next group of 2. 50, 34, 05, 75, 62. So we just kind of break it off into 2s and we'll read it left to right. And this is how we are going to get our sample. And then we'd go 91 perhaps, or we would continue to go on. But my first numbers are 1, 9, so 19. So that means Shira would be selected for my sample. Next one is 22. Will would be selected. Next one is 39. Taina or Tiana. Next one is 50. Yanira. Next one's 34. Now it's important that I selected 05. That's because it's 1 or 01, 02, 03, 04, 05, 06. So this is easier to work with. So 05 is Shante, and then 75. So I look at 75. I don't see a 75. I'm going to just skip this. I'm not going to use the 5 with another number. I'm just going to skip it. 62. I will skip that as well. 87. I will skip that. 13, Rochelle. 96, I will skip. 40, Adele. And now I have a group of 8, okay? And this would be different if I started at a different row. Let's say I started at, the second row. We'd have 12, which was Marlo. 53, I would skip. 14, Danny. 25, Kina. 44, Etta. 82, skip. 85, skip. 37, Roscoe. 36, Felix. That's 1, 2, 3, 4, 5, 6. 76, skip. 47, Shoshana. And 15, Leona. Okay? So that's the idea. Now, let's take this situation. I want to randomly select 4 people from the following list of people using the random number generator list above. Okay, well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go ahead and try to pick. Okay, 19. Nope. 22. Nope. 39. Nope. 50. Nope. 34. Nope. Okay, 5. I selected 5. That's 1. Okay, 75. Nope. 62. Nope. 87. Nope. 13. Nope. 96. Nope. Do we notice the problem here? It's going to be really, really tough to get, 4 people if we keep doing this. Maybe there's another way. Well, maybe we could start the numbers a little bit differently. Let's erase only the slide. Maybe I could say, what if this started at 11? And this was 12, 13. Let's see, does that help? 14, 15, 16, 17, 18, 19, and this would be 20. Oh, there's 19. I got that. Nope, 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 nope. So even tougher, right? Do we have a 13? Yeah, we got 13. Okay, that's the second one. Okay, so that's maybe a little bit better if we, pick a value. But there's an even easier method. What happens if I just go ahead and start, instead of from 1 to 10, which is a one-digit numbers, and then we get to 10, that's a two-digit number. What if I just go 0 to 9? All of a sudden, this is easier. Or maybe I say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 0. Well, now I could select number 1, Tracy, number 9, Harmony, number 2, Angeline. I'd skip number 2, and then number 3, Candace. And all of a sudden I've selected 4 people. So that's easier. That also helps if you have like something from 1 to 100. It's going to be tough to do 1 to 100 because if you have this 100th thing, that means you're going to be looking at 3-digit values. And 871 is not between 1 and 100. 562 is not between 1 and 100. Instead, you can go from 0 to 99, making sure you have all just 2-digit values, and that would cover it. Okay, so that's how you'd use a table of random digits to create a random sample. Little cartoon says over here we have our random number generator for accounting. This guy keeps saying 9. Are you sure that's random? That's the problem with random is you can never be sure. It's just a funny thing that says like this, though it appears not to be random. Randomness sometimes causes things to occur in a row. So that's why the whole joke, you can never be sure. We'll talk about probability more in the future. The beginning of the second semester is my favorite unit, probability. Okay, next is our stratified sample. This is a good sample. I like this sampling technique. What we do is we take our population, we split it into groups. So this is like group 1, group 2, group 3. And they have different kind of numbers in our groups. And what we'll do is we'll take a simple random sample from each of these groups, and we'll combine those to create our statistics and to do our analysis. So this is what stratified sampling is. You'll first divide the population into groups, which are called strata. You'll take a simple random sample from each of the groups. What you end up creating is 3 different statistics for each different group that can be compared to the group's population parameter. And then you could take all 3 of these and create a statistic that would be good for the entire population. So we just split into groups, and we'll talk about that more in a little bit. Systematic sampling, you start at a random chosen subject, so the 4th person, and then instead of just going random from there, you will take every nth person. So start at the 4th person and sample every 10th person after. So you start at the 4th, and then you'll count 10 back, and you'll do the next person, count 10 back, do the next person. This is good for just a random list of people rather than like something that's alphabetized. Going back to the stratified sample, this is to ensure that there's an accurate representation of the population you are interested in. So let's say we are talking about a school. Georgia Tech is a student population that is 2/3 male and 1/3 female. Someone wants to survey that population by picking random students. What could happen? Well, just by randomness, you could end up with a sample that is all male. And say you wanted, Georgia Tech wanted the opinion of, the cafeteria food that they serve. You probably want to make sure you are sampling a good representative of your population. So you want to make sure you get males and females. So sometimes just a simple random sample will not give you that. So instead, we would do a stratified sample, which would be you would take an equal percentage of each group, and it's an equal percentage of each group to make up your sample. So if Georgia Tech had 1,000 females and 2,000 males in its population, and you wanted just a sample of 30 students that you'd ask how the cafeteria food is, you'd probably take 10 females, which is 1% of your female population, and 20 males, which is also 1% of your male population. Now the key is this is equal. We're not going to take, 15 and 15. Because that would unbalance the distribution of the groups. We have 2/3 males and 1/3 females. We want to make sure in our sample 2/3 of them are males and 1/3 of them are females. So we would take a specific percentage of both populations to make sure we had the right sample of the students. Okay. Here are some of the bias samples that we said were bad samples. They had the frowny faces. Voluntary samples, which is just call-ins or, people, I think in the prelude we talked about an example when people wrote into a newspaper responding to a question, and it's really the people who feel very, very strongly about something one way or the other that are going to write in, compared to just, people who have opinions, but maybe not extremely strong opinions, which are not getting, are not a part of those samples that are being produced. So that's an example of a voluntary response that are bad. Convenience samples, just talking to people who are willing to talk to you. Judgment samples, people that you pick as experts. You don't know necessarily what an expert, and experts are not necessarily people who know what other people are thinking about. And just quickie polls, maybe doing something once, having a small sample size rather than a larger sample size, you won't get good data. Okay, or friends and family, that could be like a convenience or a quickie poll. Okay, avoiding bias in surveys, kind of just the key thing to avoid bias is to have a large enough sample, large and random sample. That is reflective of the population. But they talk about like asking questions, what type of questions you're asking, ensuring confidentiality, stuff like that. That's not as, that's important, but to avoid bias, get a large sample. Here are some videos that you should watch. Pause and definitely watch this one. This is what we're going to watch in class. However, the Smart Recorder software does not do well on videos. So instead, you're going to have to type this in, learner.org, VOD, and this is a good video that talks about the sampling methods. Okay. Your homework is your Gallup polls article. The Gallup poll is a poll that gives opinions about what people think in the population. We talk about how in the article it talks about how it's conducted, and you have a worksheet to answer those questions, and then you also have some book work. Okay, so watch the video and then work on your homework. And the video is going to definitely help with things. Okay, and that's it. Thank you very much for watching the video and paying attention.